Hey guys, this is Unit 6.2, Day 8 classwork. We are in logarithmic functions. So today we learned in class how to solve logarithmic functions, beginning with problems that have the word log on both sides of the equal sign. So please remember that it can only have the word log and base and log and base, one time on each side. If that is the case where the word log and base are on both sides once, you may set the arguments. Okay, remember this is the argument. You may set the arguments equal to each other. So 5x plus 9 equals 6x. And now solve for x. Let me make this a little bit bigger. There we go. All right, so I'm going to subtract 5x from both sides. A lot of you can do the algebra part. We're just getting you set up. That's 0, 9 equals x. Now, there's our answer. X equals 9. In order to verify that that is an accurate answer, we need to go back up into the problem and make sure that our argument, I'm going to put a little side note out here, our argument cannot be 0, or negative. Okay? So I'm talking about the argument. I'm talking about just this part. So all I'm going to do is substitute 9 in there. So this is 5 times 9 plus 9, which is 45 plus 9, which is 54. It is positive. Good to go. So as long, and the other one is 6 times 9, which is 54. They should be the same because we have this equal to. So as long as you have proven that it's positive, you can put a check by that. It lets me know you checked it, and your answer is good. Okay? Let's look. I'm going to skip number 2, and I'm going to do number 3. Okay? Just like before, I have the log of 9 on this side and the log of 9 on this side. Once I have one log of 9 on both sides, one on this side, one on that side, I can take the arguments, 6 minus 3w, and set them equal to each other. And now I'm solving for w. So I'm going to add 3w to both sides. And I get 6 equals w. Now, I have to check and make sure this is correct. So I'm going to take my argument and I'm going to plug it in. So we have 6 minus 3 times 6 equals. So multiplying in PEMDAS, multiplying comes first. This is negative 18. So 6 minus 18 is negative 12. You may not have a negative argument, so this answer gets crossed out and you write no solution. So I'm showing you different examples. All right, problem 4. Let's look at problem 4. So I have a log and a log, base 10 on both. Ooh, but they're both, I have 2 now on this side, and I only have 1 on this side. Now remember, the only way you can set the arguments equal to each other is if there is 1 log on the left and 1 log of the right on the equal sign. So I have to do something with this. I have to condense this, which we've talked about condensing, into one term. So I'm going to make it the log. I write it one time. Base 10 is invisible. And I'm going to put these two together because this plus sign that's right here means multiply the two arguments times 4. Y plus 5 times 4 equals, and I don't have to do anything on this side, log of 72. Now look, I have 1 log and 1 log. So now I can set the arguments equal to each other. So I have y plus 5 times 4 equals 72. This is all one big argument because I need to distribute. So this becomes 4y plus 20 equals 72, and now solve for y. Subtract 20. You get 4y equals 52. Divide by 4. And you get y equals 13. Now let's check and make sure it works. So 13 plus 5 is 18. That is good. It is not a negative. You don't have to do the 4 is already there and the 72 is already there. We just have to make sure there is no negative arguments. This is good. All right, let's move on to number 5. Now, remember from last week, when there is a number in front of the word log, it becomes the exponent. So this becomes the log base 7 of 4 to the 3rd power equals, nothing happens here, just going to rewrite it, log base 7 of 4a minus 8. Now, again, log once on that side, once on this side, we're good to go. And I can write 4 cubed equals 4a minus 8. Now 4 cubed is 64 equals 4a minus 8. I'm going to add 8 to both sides. You get 72 equals 4a. Divide by 4. Where's my calculator? And a equals 18. That's my answer I got. Let's go back up here and check. 4 times 18 is definitely, this makes this whole thing positive. So check. Okay? All right, number 6. Now I have a minus sign here, but let's check something. I have log base 4 and log base 4. 2 of them on this side, 1 of them on this side. So I need to condense the left side. So I'm going to write log base 4 once. I know this minus sign means division. So my 4 is going to go on the bottom in the denominator, and 68 goes on the top, equals log base 4 of 3n plus 11. Now I'm lucky. I have 1 log and 1 log. Now I can set my argument. 68 divided by 4 equals 3n plus 11. So 68 divided by 4 is 17. 17 equals 3n plus 11. Subtract 11 from both sides. You get 6 equals 3n. Divide by 3. And you get n equals 2. Throw it back in here. 6 plus 11 is positive. Check. Good answer. Okay? All right, let's try 7 and 8. All right, so if we look at this, we have a 1/2 in the front. That means it has to become the exponent, nothing on this side. So now I have log base 6 of 25 to the 1/2 power equals log base 6 of 23 minus 4w. All right, logs are the same. Log base 6, log base 6. So 25 to the 1/2 power equals 23 minus 4w. This is 5. equals 23 minus 4w. I'm going to bring this 23 to the other side. And I get 18 equals negative 4w, negative 18, okay? Divide by negative 4, and you get w equals 9/2. All right, and if I stick 9/2 in here, I get a positive number, so this is good. Check. All right, I am actually going to do, let me see, do I have 9 and 10 showing up? Let's see if I can make it show up. I don't know if I can make it show up. Let me see if I can find it. There we go, 9 and 10. All right, I'm going to do number 9 because that'll help you when we move into the next part in the next video. Okay, so here we go. Oops, let's keep it where it is. So log 4, log 4. Good, not a whole lot I need to do. So now I need to set m squared equal to 18 minus 7m. Okay? Now, anytime I have a squared, that means I want to make it equal to 0. I do not want to make the m squared negative, so I'm going to move all of the stuff on the right side over here. So I'm going to add 7m, and I'm going to subtract 18. So I'm going to add 7m, subtract 18. I'm going to do it all in one fell swoop. So we have m squared plus 7m minus 18 equals 0. Those cancel, those cancel. Now, when this is the case, I have two choices. I have a trinomial, so I can do the quadratic formula. I'm going to put it over here so you can see it, because I'm solving. So you can use the quadratic formula, which is opposite b plus or minus square root b squared minus 4ac all over 2a. Or I can do the box method. Okay, your choice. Okay, I'm going to do the quadratic. It's a lot easier as long as I know a is 1, b is 7, and c is negative 18. So here we go, opposite b. So negative 7 plus or minus, because I have two equations. Anytime I have m squared, I have two answers. B is 7, I'm going to put it in parentheses, squared minus 4, A is 1, C is negative 18, all over 2 times 1. Okay? I'm not going to do this problem here, it's the same thing, so I'm going to keep working. We're just not working on this one. All right, so I'm going to go ahead and put it in my calculator. I'm going to pause it, and I'm going to get my two answers, and I'll be right back. Okay, so I put this formula in my calculator twice, one with a plus, one with a minus. And I got two answers. I got x equals 2, and I got x equals negative 9. Now, they both could work. Maybe only one of them works. Maybe none of them works. So let's see what this is. Now, they both work for m squared. Because if I put 2 squared here, I get a positive 4. That works. If I put negative 9 squared, I get a positive 81. So that works. So both of these actually work. So 2 squared is 4. That's positive. Negative 9 squared is 81. That's positive. So they both are good answers. Okay, now if you went back here and you put it in 18 minus 7 times 2 is 18 minus 14. It gives you 4, positive answer. Same thing with negative 9. It also gives you a positive answer. So both of these work. Check them off the box. All right, I'm moving on to the second part.